Well, thank you, Laura, for the introduction, and Samira too, and for inviting us. We are very happy to give you this little presentation, which will talk about what it is to live on a warming planet. So we are, we are 4 PhD students from the Potsdam Institute for Climate Impact Research, and we began recently our PhDs, and we are working broadly on the impacts of climate change on society and on the economy. And yeah, so we have 2 Germans with us, so Annika and Lennart, and Max and I are not German, so that's why the talk is in English, because yeah, well, our German is not super fluent, so that will be clearer in English. So let's begin with something very basic. So I don't know if you ever seen this graph, but that's what we call warming stripes. And so on this graph, so each vertical line, each stripe represents the average temperature on the year over the planet. And so you have the average temperature from 1850 to today, and from today to 2200. And so what we can see, well, and the more red, the darker red stripe is, the warmer the climate was in that year. And what we can see clearly is that the planet is warming and will be warming in the future. And so during this talk, we will explore a bit what it means to say that we live in a warming planet, and what does this "we are here" that we see in the middle of the graph mean. So basically, concerning the organization, the structure of the talk, so we will have 4 different parts. So first of all, I will give you a small introduction on how do we do as climate scientists to work in the future, and what does it mean to, what can we say about the future of climate? Then Max will tell you a bit about the effect of the increase of temperature. Then Lennart will talk more in detail about the extreme weather events and their influence all over the globe. And finally, Annika will conclude on some impacts on climate change on society as a whole. So first of all, so considering the facts, so here we have a nice graph of the temperature of the Earth on land and ocean from the beginning of the industrial era and today. And so we see that the temperature of Earth has been rising almost continuously during this period. And we have already warmed for about 1 degree Celsius since the pre-industrial era. And so we know that this will continue in the future. And that's a problem because it already has a lot of impacts all around the world. So that's an infographic from the IPCC report from 2014, which represents some events, some impacts of climate change which happen around the world and that are related to climate change. So you have some impacts in blue related to physical systems. So for instance, you have ice sheets melting, you have floods, river floods, you have droughts, you have coastal erosion, you have sea level rise. Then you have effects on ecosystems. So you have, for instance, wildfire, as we've seen in Australia this winter, on marine ecosystems. And ultimately, we also have impacts on human being, on food production, on health, on economics. And we'll go to that a bit further in the talk. Here, my point is to say, well, I don't know if you ever wondered, how do we do as climate scientists to talk about the future warming of the Earth? Because, well, obviously we are scientists, but not magicians. And we cannot know exactly what will happen in the future. We don't know how much greenhouse gases will emit in the future. We do not know exactly how the planet will react to additional warming. But still, we need to do science to give insights on what could happen in the future. So for that purpose, the climate scientists all around the world decided to create 2 sets of scenarios that I will introduce to you right now that are super useful to understand the climate science. So first of all, you have what we call the representative concentration pathways, so which are basically scenarios for climate physics. So those scenarios are for each year, you will have a certain concentration of greenhouse gases into the atmosphere. So that's what we see on the left. I will point here. So that's what we see on the left graph. So we have 4 different RCPs, so representative concentration pathway. And here for the 4 RCPs, we have the amount of greenhouse gases in the atmosphere in 2100. And so in CO2, in CH4, in nitrous oxide. And so those scenarios are useful to do really climate physics and to test the climate models. And so that's what we can see on the right. That's an example of utilization of those scenarios. So here you have on the x-axis, so the time, so the years, and on the y-axis, the global warming. And so we can say if we follow this scenario here, which is RCP 2.6, which is basically an optimistic scenario, in 2100 will be around 1 degree of global warming. And if we follow this scenario, which is RCP 8.5, so which is a pessimistic scenario, we'll get to around 4 degrees of global warming. And so you can see that we do not have only a single line, we also have a shaded area around the estimate, which comes from the fact that when we use climate models, we use different climate models that different teams of scientists are developing all around the world. And those different climate models give different results. So that's why we do not have a single value, but we have an estimate of the possible values that we could reach. And so here you can see for the 4 different scenarios that we mentioned on the left, the global warming on the planet that we would have. So those representative concentration pathways are super useful for doing climate physics. But that's not enough to study the effects of climate change on us, on humans, because of course, what will happen to human beings because of climate change depends on how much warming we will have, but obviously it depends a lot on the society that we will have at that time. And so to fill that gap, the climate community came with another set of scenarios, which is called the shared socioeconomic pathways, SSPs, and which are basically scenarios or narratives to describe what the world society could look like in the future. And so you have 5 different socioeconomic pathways, 5 different scenarios that you can classify on 2 different axes. Oops. So you have the x-axis, so how much challenging they are for adapting to a warming climate, and how difficult they will, or how challenging they will be to mitigate climate change. So very quickly, so those 5 shared socioeconomic pathways represent very, how to say, stereotypes of what a future society could be. So for instance, you have SSP1, which is a sustainable scenario where you suppose that you have a lot of green technologies, you have a low level of inequality, you have low poverty, you have a lot of education, people are really educated, and well, that's like a fairy world where everything is going on and a lot of international cooperation. And so which would obviously be a less challenging scenario. Then you have middle of the road, which is a bit like a medium, an intermediate scenario. Then you have SSP3, so regional rivalry, where basically you suppose that the earth is really fragmented, that you do not have cooperation at all between countries. You have a lot of local competition on resources and a lot of inequalities. So, and that would be obviously the most difficult scenario for both adaptation and mitigation. Then you have SSP4 inequality, where you basically have a world split in 2, where you have rich people that are getting super well and that have a lot of clean technologies and that are super rich and very educated. And on the other side, you have a lot of very poor people, uneducated, that do not have access to education or to technology. And finally, you have SSP5, which is called fossil fuel development, where basically you prioritize economic growth, and you have high economic growth. You use a lot of fossil fuel, and a lot of coal, a lot of oil, and yeah, that's a scenario where you would obviously emit a lot of greenhouse gases, so that's very bad for mitigation. But at the same time, you would have a lot of resources to adapt to climate change. So to wrap this introduction up, so what you have to take away here is that so Earth is warming. We know it for sure, and as long as we emit greenhouse gases, it will continue to warm. And when we talk about so to be able to say something about the future, climate scientists use scenarios. The idea is not to say we'll go exactly to this scenario. We are not trying to predict what will happen in the future, but we are trying to say we are using a kind of what if approach, and we are saying, okay, if we go in that direction in terms of society, like a lot of inequality, low cooperation, etc., and that we emit that much greenhouse gases, then we will have those impacts that happen. And the idea is so to say, well, that's what is possible, and we'll go somewhere in between all that. And yeah, and the idea is to have some insights, to have some ideas of what could happen in the future, to be able to prepare ourselves. Now we'll go a bit further in those impacts, and I will leave the mic to Max, who will tell you about some impacts of eating the planet on the society.
Cool, thanks very much, Timothy. I just want to check quickly that you can all hear me fine. Thumbs up from someone, amazing. Yeah, thanks very much for joining, and yeah, thanks Timothy for that introduction to these socioeconomic and climate scenarios. This is a bit of personal advice. I think they're tools that are used really widely amongst different climate impact research. So if you can have just sort of some idea of what the different abbreviations and acronyms mean, I think it can give you access to like a lot of different scientific literature that you otherwise might not have. So I hope you're able to take something helpful away from that. So yeah, Timothy is right to emphasize that we don't know exactly what future the planet is going to take, because we don't know what choices we're going to make as a society. We don't know how society is going to evolve. But he's also definitely right to emphasize that it's clear that under all these different possible future scenarios, temperatures are going to be increasing. And he also showed you just a brief infographic about the sort of many different types of negative implications of higher temperatures on the world, from sea level rise to increased frequency of droughts and floods. But it's also quite important for us to ask what's perhaps a simpler question, just what the direct effect of living with higher temperatures will be on our society. And there's been some quite important work that's happened on that question over the last 5 years that I'd like to share with you. And it's in particular trying to address the question of what the effect of higher temperatures are on economic productivity and economic well-being. So a number of studies had initially tried to look at how different specific elements of the economy respond to different temperatures. And perhaps unsurprisingly, the first place people looked was in agriculture, because it's a pretty reasonable assumption that how much you can grow crops and stuff is very dependent on your underlying climatic conditions. And this graph shows the results from a particular study where researchers looked at the effect of different temperatures on the yield of maize crops. And so on the y-axis, we've got the change in the annual maize yield, so the change in the amount of maize crops that are produced. And on the x-axis, we've got the temperature in a given day. And what we see, quite interestingly, is that the yields are independent of temperature all the way up until a particular sort of critical temperature at about 20 to 30 degrees. And if temperatures increase beyond that, suddenly you get really drastic decreases in the productivity of yield crops. So if we could go on to the next slide, Timothy, as well. But it was perhaps more surprising for researchers to find similar effects in like non-agricultural elements of the economy, such as labor. So this graph shows a very similar response, but not from crops, from the extent of labor that can be supplied from a separate study as well. And again, we see that the amount of labor that can be supplied is pretty much independent of temperature. It's flat until a particular temperature threshold, beyond which, the amount of labor that can be supplied decreases drastically. And if we can click on, then another little graph will come up. Yeah, exactly, which shows another study which showed a similar effect, but for labor productivity. And I mean, I think for any of you who might have been studying or working at home over these past weeks, as like we're getting towards the peak of summer, you might have maybe even been experiencing some of these effects. I mean, like me certainly in these last few days trying to work with the window open while beginning to sweat, like it makes me think of this stuff, and I'm like, oh yeah, it's actually it actually happens. It's actually real. So if we can click onto the next one as well, Timothy. So yeah, the sort of meat of the study that I'd like to talk about focused on asking the question whether changes in temperature cause noticeable effects actually in the total output of an economy, rather than in just these individual elements. And one way that you might try and go about answering that question is just to look at the different countries across the world and look at the size of their economies and look at the different temperatures that they have. And I mean, if we look at this just map of the world here, you could quite easily notice that wealthier nations, such as countries in Europe or the US, tend to have much lower temperatures than relatively poorer nations, such as those in sub-Saharan Africa. And some researchers initially sort of use this to try and make a claim that higher temperatures lead to lower economic productivity and lower economic outputs. But making comparisons like that's quite problematic and not completely robust, because there's lots of different factors that explain why the economy of a hot country in Africa is smaller than, say, the economy of a colder country in Europe. So instead what we do, which we can see something of in this graph that's just come up, is it's the researchers in this study, they tried to, instead of comparing one country to another different country, they took one country and compared it to itself, but just in different years. And what I mean by that is that you might take the US, and so that's what this graph is showing. It's showing the annual average temperature of the US over time, and we can look at how the temperature fluctuates. So there's generally this blue trend of global warming, as we expect, but the temperature in each year in purple fluctuates around that trend every year. And what this study managed to do is to ask whether those purple fluctuations in the average temperature of that country have any relation to fluctuations in the economic growth, which if Timothy clicks as well, we'll see a little time series of as well. And yeah, the study managed to have data from all different countries across the world for temperature and economic growth in each year, and they found quite significant results that, yeah, generally increases in temperature lead to reductions in economic growth. And this was, there were a number of reasons that this was quite groundbreaking, because it was breaking a lot of underlying economic assumptions. It essentially showed that rich and poor countries are affected to the same extent, and countries that have a predominantly agricultural economy are also affected to the same extent in comparison to countries whose economy is not predominantly agricultural. So we can click on to the next slide as well. But yeah, so the size of the effect actually depends, quite interestingly, on the sort of underlying temperature that that country is used to experiencing. So if we have like a really, really cold country, like Russia, whose annual average temperature is pretty low, increases in temperature in that nation actually may lead to increases in the productivity of that country and benefit them from an economic perspective. But for the vast majority of the rest of the world, and in particular for countries whose average annual temperature is warmer, if the temperature increases, that's pretty much always associated with decreases in the economic growth and damages in an economic sense. So this immediately has, well, no, we'll stay on that last slide. That's all right, Timothy. No worries, no worries. This is pretty much like immediately important implications in the context of climate change, obviously, because it suggests that as global warming progresses and temperatures change across the world, the productivity of all of the economies around the world is going to change, and our well-being, our economic well-being is going to change as a result. So the study asked what, say, is the historical impact of that warming, and that's what this graph on this slide is showing. It's the country-level economic impact of the historical global warming. On the left-hand panel in A, it's the impact over 50 years from 1961 to 2010. And on the right, it's just over 20 years from 1991 to 2010. And you can see there's sort of this different pattern, like the very northern countries like Canada, Russia, based on this analysis, they've actually benefited from global warming because, as we said, they are countries with a much lower average temperature, so increases in temperature benefit their productivity. But for the rest of the world, pretty much the global warming has led to pretty severe economic impacts. And for sub-Saharan Africa, these impacts have a size of up to 40% in terms of GDP per capita, which is just like the size of the economy per person in a country, which is really significant. And some sort of non-economic implications of this are that global warming has essentially led to increases in global inequality, because these poorer nations, which tend to lie at low latitudes and tend to have higher temperatures, they've suffered more from these rising temperatures than the richer nations, which tend to lie further north. And on top of that as well, it has also implications for climate justice, because a lot of these low latitude lying countries, have much lower historical emissions of greenhouse gases, and yet they're the ones who've historically already suffered most from climate change. And I think if you tune in for some of the later talks in this workshop series, you'll get to hear more about climate justice and inequality in relation to climate change, which is an important topic. But we can jump on to the next slide now, which is just to try and talk a little bit about the possible future impact of this warming on economies of the world. So as Timothy explained, the exact future impact is not going to just be dependent on how much the world heats, but also on the different socioeconomic scenario that we might have in the future. So that's what these two figures here are describing. In the left-hand panel, we've got SSP 5, so the socioeconomic scenario 5, which, yeah, exactly there, which describes a world in which the baseline level of economic productivity and growth is very high, whereas on the right-hand side, we have SSP 3, which describes a scenario in which the baseline level of economic productivity is lower. And in each figure, the central vertical line is describing the incomes of these different countries today. And the red lines that move out to the left, they're showing the development of those economies over time in a scenario with climate change. And the ones on the right that are gray, they're showing the development of those economies over time in a scenario without climate change. So for both scenarios, or we can stay with this one for a second. Yeah, that's cool. So in both scenarios, there's quite an immediate important implication, which is that 77% of all countries across the world are poorer with climate change by the end of the century than they would be without it. And that's consistent between both of these socioeconomic scenarios. But in some of the cases, climate change might even make some of those countries poorer by the end of the century than they even are today. And that's then dependent on which socioeconomic scenario we choose. So if we assume that the world is going to be going along a very high growth, high economic productivity future scenario, then only 4% of countries are going to be poorer in 2100 than they are today because of climate change. But if we assume that the baseline growth of different economies across the world is much lower, then that figure rises to 43%, and 43% of countries across the world would be poorer in 2100 than they are today as a result of climate change. So that's just some of the impacts from this assessment. And I think it's really important to keep in mind that this is one small part of the picture of the economic costs of climate change, as it's just looking at the direct effect of temperature on productivity. And there's many, many other consequences of climate change which aren't accounted for by this, such as sea level rise and increasing frequency of extreme events and things like this. So this is just part of the picture. But luckily next, Lennart is going to pick up by talking a little bit more about extreme events, and in particular how we can try and assess how the damages from extreme events might spread across the world. So let's say thanks and pass on to Lennart.
Yeah, thanks Max for this interesting discussion about temperature. And now we will discuss extreme events and global trade. Okay, since I can't cover this complete topic, I will focus on three main questions. First, are the extreme events increasing, and maybe even a little bit of why? There we could have the first picture. Perfect. And secondly, why do we have to consider the economic network if we are looking at extreme events which are in a certain place at a certain time? Yeah, and there we have another picture. Yes, thank you. And finally, I will put everything together. What can we, or what can models tell us about the economic consequences and connections of extreme events and global trade? Okay, so on to the next slide. Increasing extreme events. Yeah, we have all this subjective feeling that extreme heat waves, etc., are increasing, but especially we have also scientific evidence that it's connected to global warming. For example, here this one study I'm citing from colleagues from PIC, and especially heat waves and extreme precipitation events, as we see on the next pictures. There the connection is quite clear between increasing warming and increasing amount of heavy precipitation events. And okay, for a very simple physical explanation, I have put the next line on the slides that, okay, we have increasing global temperature. This increases the amount of water vapor in the atmosphere, and this enables more heavy precipitation events. Yeah, there's also a lot more complicated and detailed analysis of this, for example, in this one study of researchers at MIT. And okay, now we'll have some concrete example of one specific extreme event, and their colleagues from our working group analyzed river flood risk. Okay, if we have more heavy precipitation, yeah, this leads to more river flood risk. We can see on the left-hand panel the immediate increase in affected persons by river floods. And yeah, it's an overview of the whole globe, and we can conclude that most major river basins experience some kind of increase in flood risk. Population-wise, especially India and China are noticeable simply because there are a lot of people are living, but also in Germany there's a considerable amount of flood risk increase, as you can see on panel B in the left figure. And as a result of this flood risk increase, the right-hand side figure just shows how much the protection level needs to be increased to maintain the current level of protection against river floods. And yeah, it's this very similar picture we need. This shows like another side of climate change. We will have to mitigate it and avoid greenhouse gas emissions, but there will also be some kind of adaptation necessary, for example, by higher river dams. Okay, this is a basic concept, and now a very concrete, the Thailand floods of 2011, they caused $46 billion of direct economic damages. But not only this, but also some indirect effects, like the prices of hard disk drives increased by 20 to 40%, according to some sources, simply because the production of hard disks is very much concentrated in Thailand. And so the prices increased because the supply was a little bit smaller than demand. Okay, and just on a quick side note, similar effects we can maybe see related to COVID-19. Some kind of supply chain disruption leads to disruptions in the global trade network. As a very specific example, I picked up this from a German news outlet, the delivery of tractor parts from Italy to Germany. It was not possible in April, and so the German tractor manufacturer had to stop production because this single part was missing for the tractors. Okay, and now we see this single extreme event had some repercussions in the global economy, and also COVID-19 obviously has, and so our working group developed a model of global trade, Acclimate, to be able to figure out this adaptation of the global supply chains, which is very complex. And basically what the model does, it takes as input some kind of extreme event, mostly weather events, but we also, like our research group did also a paper on Brexit, because it's also like a local event with certain consequences you can try to quantify. And then this input is processed by the model and spreads through the economic network, and you see how the prices develop in all the countries, how production changes, how consumption changes. And you see in this illustrative picture that you have all the economic sectors in one country represented by all these dots and all the connections in between. So it's really trying to have a full scale model of the global economy, kind of on a country basis resolution, maybe as a disclaimer. Okay, and so we have this very nice model, and we can try to combine this with the fact that extreme events are increasing, studying river floods once more, or like continuing the study of river floods. Colleagues from our research group showed that firstly, the direct damages of river floods increase, especially in China, but also in the EU and the United States. It's for the near-term future, like the study was for the time horizon of 2016 to 2035. And okay, first step is we have this increasing direct economic damages. The second step, as I tried to explain beforehand, is we have some kind of indirect effects in the trade network. And firstly, the losses which result from the floods in China are transferred to the EU and the USA, mainly, also to other countries. And then after this loss transfer, there's also like a next level of impacts of this direct damages in China, because production in China is reduced because of the damages. The European Union and the US are able to increase their exports to China because they substitute for some producers in China, resulting in some kind of compensation, like for the loss, because they can accumulate some kind of profit from this increased exports. And for the EU, due to the relatively balanced trade relations with China, it almost offsets the losses, like the share, there remain some losses, but they are not as big as for the US, because the unbalanced trade of the US and China, the increasing exports from the US can't counterbalance the losses imported from China. Okay, and so as a small conclusion, we see that by combining these physical models of river floods and extreme events with a model of the economic network, we realize that an extreme event is not only a local event which has local damages, but it's transmitted along the supply chains to the whole world, more or less. And similar effects can be observed for non-economic factors like societal impacts of warming, and Annika will pick up now with this topic.
Exactly. Thank you, Leonard. Can you hear me all right? Perfect. Okay, so for Max and Leonard, we have now already heard quite a lot about the economic impacts of climate change. And now we want to go one step further and actually ask ourselves, what impact will living on a warmer planet have for our societies? So we live in close connection with the environment, and I think all of you experience in your own everyday lives that weather is really one of the key influences we all experience. Actually, Cicero already said, "The minds of men do the weather share, dark or serene, as the days fall off air." And on the next slide, we can see that most humans actually live in a relatively narrow niche of the Earth's climate, where mean annual temperatures are around 11 to 15 degrees Celsius. And we can interpret this mean annual temperature range as a suitability measure, where places that have more or less mean annual temperature will be slightly less suitable for living. And then we can project how this temperature niche is going to develop under future warming. If we consider a pessimistic climate scenario, the geographic areas that experience these temperatures will shift drastically until 2070. So we can see this here on the map. The red indicates where the suitability will decrease, and the green areas indicate where the suitability will increase. And these areas, which are like really dark red, just for reference, have a mean annual temperature of around 29 degrees Celsius. So what this means, sorry, one slide back. Yeah, thank you. So what this means is that over the coming decades, the human climate niche is projected to move higher in latitudes, while at the same time, the populations are projected to expand predominantly at lower latitudes, where it's more red. Exactly. So this aggravates the mismatch between the expected distributions of humans on the planet and climate. So what effects could this have? Next slide, please. If the environment around us changes so drastically, people might be forced to leave their homes. Shorthand internal climate migration is in the Groundwell report by the World Bank defined as migration that can largely be attributed to the slow onset impacts of climate change, which can be owing to shifts in water availability or crop productivity, or to factors such as sea level rise or storm surges. And just to make this really clear, internal climate migrants migrate within their country of origin, so they don't cross any borders. And if we consider sub-Saharan Africa, South Asia, and Latin America, the number of internal climate migrants could reach more than 143 million by 2050. So this number is obviously depending on the emission scenario. However, in every scenario, the poorest people and the poorest country are hardest hit. And internal migration doesn't necessarily have to be a bad thing, because it can also help with the shift of economies and things, but it definitely is a huge infrastructure and cultural challenge for the country that the countries might not be well equipped to face. Next slide, please. However, if the country of origin does not offer a long-term prospect of a better life, international migration might be the only option. And a study found a relation between localized shocks to agriculture in developing countries, which were actually due to temperature fluctuations, and application by that country's migrants for asylum in the European Union. So the focus of the study was migration towards the European Union. And then the aggregated effect was simulated for a uniform 1 degree warming to 5 degree warming. So that means we consider the planet gets hotter everywhere by that amount, and compared to historic weather from 2000 to 2014. And that suggests predicted changes in total applications to the EU by plus 188%. So that's this red curve. And that corresponds to a pessimistic scenario. However, in the in the scenario with ambitious climate mitigation, this figure was still 28%. So they still found a substantial increase. And I think the migration crisis of 2015 has shown the structural and political challenges a strong flow of migration caused for the EU. Okay, so if we go to the next slide, I would like to talk about another important societal impact of climate change, which is the link between climate change and conflict. And I invite you to just take a moment to read this quote by Ban Ki-moon, where he is describing the Darfur conflict in 2007. And in the Darfur region of Sudan, precipitation has declined by 40% since the 1980s. And this actually coincided with the rise of the Indian Ocean, a rise in temperature, of the Indian Ocean, which is at least partly man-made. And this rise in temperature disrupted the seasonal monsoons, causing droughts in Darfur. And the violence in this region erupted during the drought and has since been pretty much ongoing. And the crisis of Darfur has, in some literature, been called the first modern-day climate change conflict. If we go to the next slide, we see here a whole range of quantitative studies comparing changes in weather observations to those in social data connected to conflict. And these studies suggest that, for example, temperature anomalies have a nearly linear relationship with violent personal crime and rape in the USA, as you can see in panels A and B, civil war incidents in Africa, as you can see on panel I, political and intergroup violence in East Africa and Kenya, as you can see in E and F. And overall, previous research indicates that deviations from mild temperatures will increase conflict risk around the globe. However, the link between climate and conflict is not restricted to armed conflict. So there's actually research from many different disciplines finding impact of heat stress on human aggression, and study setups range from things like people honk their cars more frequently in hotter weather without like a defined cause for it, or football penalties get a lot more severe in heat. So we can really see that this relationship is very prevalent across all parts of human society. If we go to the next slide, we can ask ourselves the question, well, what if hot just became the new normal? So maybe this is just what we have to live with and we should adapt to it. And to find out how well we're doing with that, some colleagues employed Twitter and used the tweet data to find out how we adapt to living in warmer relationships. So they looked at how people react to continued exposure to temperature anomalies. And they found that the remarkability of particular temperatures changes rapidly with repeated exposure. So you can see these on these graphs on the left. The red curve shows how much you tweet about a day that is exceptionally hot, depending on how many years you have experienced this hot temperature. So if it starts to be that hot for the first time, you might, or like on average, people tweet 10% more about it. But then as they continue to experience this temperature, they don't really talk about it anymore. It doesn't seem to be as remarkable anymore. And that's actually the same for exceptionally cold temperatures. But then to find out if this decline in remarkability actually coincides with the adaptation process, because maybe we just don't talk about it anymore because it's not an issue for us anymore, they looked at the sentiment of the tweets. So sentiment analysis is a tool that analyzes the content of text and can find out if it's positive or negative. And here we see that the content was negative by the time the temperatures were sort of still remarkable, but it didn't get better over time. So while the remarkability went down, the sort of negative emotion associated with it still stayed prevalent. And this could actually be interpreted as an indication for a boiling frog effect. So the boiling frog effect means that if a frog is just dropped in hot water, it will jump out and save itself. But if a frog is put into tepid water and this is brought to boil slowly, it can't perceive the danger and will be cooked to death. So we might actually not be able to realize the danger around us. Okay, so overall, the studies we have presented to you today are all very clearly show that we need to come up with preventive and adaptive measures to limit climate change on the one hand, and to mitigate to the inevitable consequences, and to adapt to the inevitable consequences it will have and already has actually in this very moment. So with this, I can just like point to the future talks in this series, in the summer school series, some of which will address climate adaptation in a bit more detail. And with that, we thank you for your attention and look forward to your questions.